So, one representative, pick amongst yourself, or two. You're going to explain the high-level key points here, and then also some of the deeper information that you want to know or highlight that you think will be useful to know. So let's start with the what is learning definition. Anybody from that group want to volunteer? Yeah. Do you want to go up and then point and then, yes, just hold it somewhat close to you.
All right, so for what is learning, when thinking about the definition, we took the main definition from the lecture on learning how to learn, and we said that the acquisition of knowledge or skills through experience, study, or being taught. And from the first reading, called What is Learning Anyway, we talked about the 9 principles of learning, which are right there. I'm not going to go through each one, unless I should.
No, that's good.
Okay.
We'll try to keep it to a couple minutes per one, but yeah.
And then there's a second reading called Reading into the Future, which also talks about more in-depth definitions of learning. And then we also wrote that the key issues in learning are increased resistance to engagement, heightened investment in grades, and dependency on digital technologies. And yeah.
I think that's good. Any questions about that? Any points that you would like clarification on from our learning experts? There was a question about, that's great, thank you, I'll take that. There were questions about the learning portfolio, and then there were questions about the exam if something like this comes up. For the learning portfolio, the question related to how much information, what information am I actually looking for? If it asks you to explain with evidence, the key point that we're looking for here is introducing the evidence and then having a sufficient explanation. You can introduce the evidence in 10 sentences if you really want to, or you can introduce it in 1, or you can introduce it in half a sentence. That's fine. If you do 10 sentences, that's going to be fairly unreasonable. But then the justification can also be a sentence or 2 sentences or 3, whatever you think is necessary to explain the point. Does that make sense? I'm judging you. There are a certain set of facts that we've established in this course. I know the facts. I'm sure you know the facts. You should have them in your learning journal. The question that I'm trying to understand, I'm trying to get you to think. Learning, I think, is this process of trying to deeply integrate information. I want to see the logic that you're applying and your ability to work with the information. Thank you. Who wants to do the model of domain learning?
Okay, so there are 3 parts to the model. Would you say parts is a good word to the model of domain learning? First is interest, and from there it can be separated to situational versus individual interest. Situational is temporary, it's immediate, it sparks initial curiosity, but it's not it's temporary, so it's fleeting, and it can distract a learner from what they're learning or what they're really interested in. And then individual learning is more deep, and it sparks a more internal commitment. Next, strategic knowledge. So there's cognitive, metacognitive, and self-regulatory. And then there's, from strategic knowledge, it could be separated to surface level strategies, which could also connect to information management, versus deep processing strategies, so that's knowledge building. And then subject matter knowledge can be separated from domain, and then a subset of domain knowledge is topic knowledge. And domain knowledge is the wideness of knowledge, the breadth, the scope, and then topic is the depth of it can be a subset, so it's the depth of knowledge. So there are stages to the domain learning. First is acclimation, then competence, then proficiency. Acclimation is low domain and topic knowledge. It's initial, reliant on situational interest, and strategy is minimal, surface level. Then competence, it's growing in breadth and depth of knowledge, more topic knowledge. Less dependent on situational, and better strategy use for learning like how to intake information. Then proficiency is high knowledge, both breadth and depth of knowledge, strong individual interest, and sophisticated strategic processing.
Cool, awesome. Any questions, any concerns, any ideas? I think the main takeaways here, obviously all of this is important, great job, but if we're gonna be a little more directed in our knowledge building or information management, I think really focusing on this table with the stages and understanding how the different factors, knowledge, interest, strategic processing, how each of those factors operate in each one of those stages. And an important question to be able to answer is, and justify, is your own placement on your chart. If I gave you a chart and I said, place yourself, could you sufficiently justify why you are doing that in relation to those three factors? Well, there's 6, but there's 2 for knowledge, 2 for interest, 2 for strategic processing. So to be able to say, my knowledge, my situational interest is at this level, that puts me here. My the 2 factors for knowledge are on this place and this place in the graph because I have this level or whatever. And then I don't want to just like explain it to you and then you just say that. But to be able to explain it in relation to those factors, I think that would be incredibly important. Any questions about that? No? Okay, let's give a round of applause. We didn't give a round of applause to our first presenter. Let's do it to both. Thank you, thank you, thank you. Who did the traditional views of expertise?
Okay, so our main sources come from the expertise slides.
Okay.
All the information that we got off of there is a roundabout of that because we assumed that everybody did their reading summaries, so they would have done that. But basically, we highlighted the 3 generations. The first generation is generic problem solving. It's stimulated by AI research. We also put that experts are studied. They isolate the characteristics of those expertises, and then it's programmed in intelligent machines. As well as expertise in the first generation essentially is efficient and effective solution of generic problems. For the second generation, it is based on knowledge-rich domain-specific problem solving. This surrounds the information processing theory, particular problem-solving tasks, and overall it's expert versus novice. And lastly, the third generation is multidimensional development. It surrounds the idea of social constructivist, social cognitive theories, and also motivational variables are necessary in this generation.
Nice. Any questions about that? There were a few questions about the relationship between AI that I talked with some of the group members with in relation to this. And I think the biggest point that we just want to walk away with here is that the first generation of expertise, you can think about it just as like knowing information or not knowing information. At this period of time, there was a lot of questioning about there was a lot of possibility about what humans could learn. So the idea is anybody can be an expert. It's just the process of accumulating a bunch of world knowledge, facts. But then the second generation, in relation to AI, you can think about it in terms of the application of those facts in a more sophisticated manner. So you had more complex computers that did more complex pattern finding, that sort of thing. And then that helped inform our ideas about experts versus novices, and it gets a little more complex there, more situational, domain specific. But then the third generation here, the model of domain learning, much more expansive. The difference here is that we're able to incorporate more of our humanness, the particular factors that lead us to being different, which will then take us to the basics of human cognition versus AI. Thank you very much. Let's give a round of applause. We have 2 people in the back that decided to do this. Taylor or Nate, who wants to? I'll do it. Yeah, okay, perfect.
Basics of human cognition and AI. Honestly, this is pretty short in my opinion. Okay. It's, I guess, self-explanatory, but cognition is just all about like memory processing, basically like how your brain works, and just like the differences between human cognition and AI cognition is like humans are more like dynamic and situational with like how like they process information, while AI is more like robotic. You know, it could process like a bunch of like data sets and things like that and like spit them out, but it can't really process things like humans can.
Let's think about, I think that's great. Let's think about the basics. So like what is like a foundational difference between what, say, a computer is doing versus what we're doing? Like what are some key experiences that we have that an AI might not have that might influence its ability to reason?
Yeah, so humans, they have sensory processes like our vision, touch, taste, things like that, our own perception. While again, AI just process like data, numbers, text, things like that, and they can't really perceive things like that.
Perfect. Okay. Yes, that's exactly it. So if I ask a question about what the foundational differences are, I think that would be a sufficient answer, obviously with a little bit more explanation and some evidence. But yes, the main idea here is that relating this to a principle of learning, that might be another thing, trying to relate these topics to different principles. The way that we learn is framed by our unique experiences. The way that we process that information helps us determine how we approach new problems, how we transfer information, how we're able to learn. And so like you might say that AI is able to learn by identifying information that's useful to it, but then we're at this key question here of what is useful to an AI system as it's programmed versus what is useful to a human being. And like right now, there's a difference here. I'm not saying that we'll never come to a point where an AI can get sensory motor data, but at this point in time, it is not. I think that's great, Nate. Any questions? Going once, going twice. Thank you. Okay. Let's do the IMKB analysis. So before we get into this one, we're going to do the IMKB analysis, and we're going to do the day in the life analysis. And for part of this final bit of like additional information, we're going to like go over some of the information that we would like to see in the data analysis. We did that one day. I think it was trepid. I don't think we went in as deep as we should have for the data analysis. The point, and there are also questions here that I want to like preempt. Like what information am I actually looking for in the analysis of the class and personal data for IMKB and day in the life? I think if you're trying to create a mental model of what I'm going to ask you questions on, I think a good way to look at it is what is the amount of energy that this person in their life has devoted to this thing, and does that correlate or predict whether they think it's important? And if you think I think it's important, then you might think he thinks it's important enough to put it on an exam. So that's a hint. And so the IMKB analysis and the day in the life analysis, I have the data. Like I know what the particular datum are. I want to know what it means to you, and I want to know what it means to your classmates. I want to know, like, we have data in relation to the day in the life, we have data from like 2014. We have data from this class. We have data from last class. What trend, what story, what narrative does that tell us about what's happening to students? You have all of this other information about what learning is information management versus knowledge building. You have all of these principles. You have what makes us different from AI right now versus how we process information. What does the data show us? Does it show us that there is a difference in information management versus knowledge building across those three, across that larger time span, but at these different intervals, 2014 or 16 or whatever it was, 2024, 2025? What story does that tell? Why is it important? How does that affect knowledge building? How do you see those effects in your learning and your life? The rest of your life, you will be exposed to charts on the news, on TikTok, which I guess is also news, Instagram Reels, whatever. You might go to a school board meeting and somebody holds up a chart. You have to be able to read it, and you have to be able to understand why it's important to you. That's what I'm looking for. So there are questions about whether I need to have all, like, if you want to print out all the charts, you can. The questions that I would ask, if I were to ask questions on these topics, are related to those things that I just said. Why is it important? You have to explain that to me. Hopefully using all of these things in the course. Like, we can't just look at the data in a vacuum. We are in a class called Learning How to Learn, and we're learning things about learning how to learn, and then we're saying, wow, there's a difference in the amount of hours people spend studying. That's interesting. How does that relate to this information? How does that relate to the people in your little cohort here? Does that make sense, everybody? If it doesn't, please let me know. Okay, without further ado, I am KB Analysis. Cole, you're going to be our...
Oh, this is a mic. I didn't even realize that. Okay. So we have our little definitions here. So that was just, we wanted to set a baseline. So information management, the manipulation of data from multiple sources, focusing on short-term tasks, getting stuff done. There's not much long-term potential. Whereas knowledge building, you're creating deeper connections, analysis and processing with the intent and goal of remembering it. So that's going to be long-term tasks. You're going to hopefully carry that stuff with you for a long time. Then I just drew a little chart of our class averages. I couldn't draw them all, but there's a lot of charts.
There's a lot of charts.
Which gets into for the readings and resources. The class slides from that day is going to be your main thing, especially for the analysis portion, and then of course the reading if you need like more stuff in the terms. But then our class average, the major. So these are scores between the because the survey asked us about major and non-major. You all took it. The major IM average was 55.03. Major knowledge building was 77.98, non-major IM 62.67, non-major KB 65.64. So we had a couple demographic takeaways as well, which are from the charts that I didn't draw. So non-major KB decreased as class standing progressed. So seniors had much lower scores, or at least significantly lower scores than the freshmen, and that trend for knowledge building in non-major classes, that trend kind of carried from freshman year to senior year, even though we were like talking about the sample size a bit about freshmen being off, and I was talking about that a lot, but even though that could be a problem from sophomore year to junior year to senior year, which all had decent sample sizes, there was still that drop off in knowledge building in non-major classes. So we thought that was interesting. Then we also overall female students had higher knowledge building scores, which we talked about was also the case in previous years. So that seems to be like a trend in general. I'm sure you could come up with some interesting theories. And then also certain majors had students that had higher non-major KB scores. So we noticed that for human development, architecture/real estate, and psych. We talked about this a bit in class about why that might be, if these are majors that like relate to more non-major studies and you're kind of needing that knowledge building in all your classes. So those were our takeaways there. Yeah.
Perfect. This is great. So I think this is the perfect, if you're wondering what information do I need to take away from all of that data, the demographic takeaways here that were brought up illustrate trends in the data. That's the first step. Identify trends in the data. The second step is to then explain or relate the importance to other issues, personally, intrapersonally within your group, externally or interpersonally, which would be beyond that, and then, relating it to the class. Yes, there was a point here.
Just to make sure, but this is all based on like people within this class, right? Like
Yes.
Okay, because I mean, obviously that biases the results. Like we probably can extrapolate it to even like.
I will say for the purposes, I respect that. Statistical analysis is incredibly important. Making sure everything is above board is incredibly important. Let's just assume that these are representative.
Of like UMD or of all university students or.
Let's assume that these are representative and track with national data. We can quibble about how accurate that is. The thing is, we do this. So there's another class that does this with 60 students. There's another class. Another learning how to learn class. There's probably 100-something students every semester that end up taking, or 200 students that end up taking this, and the data in aggregate, our class is fairly representative of that data. But then we get into the problem of like, we're sampling a sample, and it's like, how accurate is that really? Let's just, for the sake of this course for now, just assume that this is representative of the national data. Does that make sense to everybody? It's okay if it doesn't. The question is like, how does this actually, is this representative? Can we make a comparison between national data from 2014 that had a lot more people versus what we're doing now? If you want to, you can make a stipulation saying, the N is small. We make these recommendations or these observations with caution because of that. But assuming that this is the national data, this is how we would interpret it. Does that make sense? Does that make sense? I think I'll just, to preempt this problem in the actual test, I think I'll state that. Assuming that this is representative, and I think there's no issues there. Nobody has any problems. Yes?
Are we going to have points taken off if we only talk about like our individual in comparison to like national data with like the IMKB or the day in the life, or like do we have to talk about the class as a whole, like trends across?
The questions, if there are questions about this, they will be specific enough in reference to like the national data. How do you? They'll be specific enough to know what to reference, but they won't be specific enough where you have to like know the particular data points. Well, okay, let me. I think your question, the concern that your question is getting at, will not apply.
Okay.
I think you'll be fine, and I think you'll know how to navigate. I think everybody will know how to navigate the question. The instructions will be clear enough. Is that a sufficient answer? Okay. I just don't want to give more information and then give it out. Joey's nodding like you should. You should. Okay, I think that's great. But again, this is the process that we want to go through here. Identify the trends, explain why it's important, referencing points in the class. Right? Okay, let's do our day in the life analysis. You want to grab that mic test?
So day in the life, first we started with just getting all of the data points. That's this first part. That's from the slides. From the slide or the readings, and also in the reading is 71% of undergraduates work, with 1 in 5 working at least 35 hours on average per week. Then some of the key takeaways from the reading here were that educators should encourage the 2-to-1 rule, which is hours of study as compared to hours in class, and also recognize the burden of coursework on students and attempt to create some resources to help students out with that. They also noted that leisure and sleep are not a waste of time in the reading's words, but are critical to student success. So it's important not to neglect those two otherwise seemingly less important groups. Then they noted that student success is dependent on proper and intentional time management. So reflecting on how you use your time and taking that into account to inform future decisions. And this right here is just noting the source for the reading. It's how college students spend their time, and the age range was 15 to 49, so that's probably an outlier, but might be useful to note. This data is from the lecture slides for when we went over like our day in the life information, as well as some past stuff. These notes are from the major breakdown for the different categories. So some like things that stand out from that chart was that for the STEM majors, they have by a significant margin the highest amount of multitasking and funnily the lowest amount of sleep. However, the art majors spent a good amount more time than most on educational activities. Multidisciplinary students had the highest work, outside of school, so that might imply that they hustle more. Health science had the highest leisure. Not really sure what you can derive from that. Here is the more important categories from the breakdown by academic standing. Didn't feel like writing it super tiny on this chart, so we've got freshman, sophomore, junior, senior in each of the categories. Interesting things to note are that sleep decreases, minimizing at junior year and then going a little bit back up senior year. Most notably is that multitasking seems to steadily increase until senior year, which might indicate that students, as they go through college, learn to manage their time better and kind of combine some things like leisure with work or travel. Work has a peak for juniors. Educational activities decreases for juniors and then rises again in senior year. And kind of unintuitively, leisure and sports increases with academic standing. So that was kind of an interesting thing. That's why I put it on. All the other categories were kind of even for all of the years. And then down here we have two pie charts from the lecture slides that are kind of emphasizing the evolution over time. But to preface these percentages, which are the numbers that are inside of the pie chart, the 2016 data does not include a multitasking category. So even though things like sleep are different between the two, you have to consider where that multitasking might actually double count. Mm-hmm. Multitasking wouldn't really add or subtract anything from sleep because you're obviously not multitasking when you're sleeping. So interesting things to note from these charts are that sleep decreases significantly on average for percentage of your day spent. The others, like education, is slightly higher for current times, but also might have some effects with multitasking. So there might be a few percentage points that went to multitasking with listening to music or watching TV while you study. Otherwise, the categories were pretty similar. So I would say that like sleep and educational activities are probably, and maybe leisure are the ones that are the most noteworthy. And yeah, that was all that we got from the day in the life data.
Thank you. Very nice. Okay. I think that was great. I was going to pull up the slides from the day in the life, but I think our process here, identify trends, explain why it's important. I think a lot of trends were identified here, and then it opens up a world of possibilities as to how we're going to interpret that data. So for me, what would be interesting if I were to look at it, which I am, I would say, okay, here are these trends with STEM, art, multidisciplinary, health sciences, whatever they are. And I would ask myself, what are the constraints, what are the influences that dictate STEM outcomes, art outcomes, multidisciplinary outcomes, and health outcomes? Like I might ask the question, like what information are they actually trying to learn? Do they actually have to learn the information, or are they information managing? Now, I can apply prior information that I have about STEM, art, multidisciplinary health sciences. Ideally, we would have had a class where people were bouncing off about like, oh, well, in my major, this is what the class situation is like. This is what's expected of me. This is what the sort of strategy that professors have, or at least what I can deduce the strategies are. And then you ask yourself a whole bunch of questions, like what principles of learning does it seem that the STEM cohort most actively follows, or that their professors actively follow? Do they preference information management or knowledge building? You can ask that for every single one of them. And you can sort of make a comparison here or relation between these ideas. Again, we have this data. We notice these trends. What does that actually mean for us? What are some consequences? Is it good if our STEM people have incredibly procedural, taxing work and they get the lowest amount of sleep? Okay, that's not good. Do we think that we're the first people in the world to ever recognize that not having sleep is good? Why does it still look like this? We don't have to have the perfect answer, but we're in the field of building theories and explanations that use the data that we have here with facts around here to explain this. And that's how we need to be looking at the data in general. So what I would recommend is looking at the data for day in the life and IM versus KB. There was a great point here. I actually looked into this, why we include multitasking and why this doesn't. Multitasking was not a consideration back in the day. The researchers didn't think it was a big problem, and so then they started adding it later. Obviously, we have this translational issue here in terms of like percentage of the day. Like Joey was saying, if you want to make a more accurate, not the most accurate, but more accurate comparison, you would compare like hours as opposed to percentages. But I won't be too hard on that. The point is just having some accurate identification of trends and then analysis applying information here. You might get a question that's like, if you were to have this, the question might be like, how does your day in the life compare to 2016 or 2015 or 2024 from last year? How does your major compare to other majors? What would be the possible reasons or justifications for that? If you can answer those questions, I think you're generally in a good position. Again, when I'm grading these questions, I'm not like, I know what the data looks like, so if you just give me something that's factually wrong here, like what the data doesn't say, that's the easiest thing. Like, thank you. But what's even easier is if you get it right, and I don't have to mark anything. So the facts, if the facts are right about the data and the trends, you're good. If you bring up facts that are accurate from the class, that's good. All you have to do from there is have a cogent, logical explanation, theory, hypothesis as to why this is occurring. I think we are all capable of doing that. But I would recommend going over those slides. This and that will be important. Obviously, all those are important. You can't run away from any of the information here. Does that make sense? Are there any questions? We've got like 7 minutes. There's one thing that I want to go over fairly quickly.
Are we not going to do the lockdown process?
Yeah. Okay, this is what I'll do. We'll do this. We have 9 minutes. I think this is fairly straightforward, and we can do this. We don't want that. Okay. Let's say you get a question about the model of domain learning versus traditional views of expertise. And I wanted you to compare and contrast. I'm not going to give you this chart, and I'm not going to give you the dimensions that I want you to contrast on. But like, for example, if I wanted to give you information management versus knowledge building, and I said compare and contrast one aspect or one characteristic between information management and knowledge building, how would we go about doing that? Yes?
You could talk about that IAM is for like short-term use, and then KB is for more long-term use, and like critical analysis versus like just like skimming over something just to memorize it.
Okay, those are two things, two different points of comparison, right? The first one was short-term versus long-term use.
Yeah.
The other one was what?
Like an example of each of them.
Okay. Let's focus on that first part. So short-term versus long-term use. How would we classify that comparison? What is the dimension?
Utility, like application.
You could do application. You could do time, right? So like that is how we want to think about comparing and contrasting. In your mind, when you come up with that comparison, you're saying, oh, this is information management does this, knowledge building does that, and they're different. That's exactly what we want, but I also want the dimension, the feature that we're talking about. And in this example, it's time or it's utility, however we define it. So if you see something on the test that says compare and contrast, like for instance, if you see something on the test that says the model of domain learning versus traditional views of expertise, I'm not going to give you these, but I might say like compare and contrast these two things. I want you to like find the dimension. Maybe it's time. Maybe it's beliefs. Maybe it's something, whatever it is, and describe the two differences. Does that make sense to everybody? This is online, by the way. The main point here is that you can say two statements. You can say information management is about selectively, you could say it's about selectivity. Information management is about picking and choosing what information is useful. Deep knowledge building is also about picking what's useful, but it's instantiated differently. Well, that's a good comparison. Does anybody else have another example comparison for information management and knowledge building? I want to like drive the point home. If you want to make a comparison, explain what you're comparing against. Does that make sense? Like if I have two track stars, how do I compare which one's better? It's like super simple. Who runs faster? So what is the dimension that I'm analyzing them across? Speed. Yeah. I'm like right in this camera. Does that make sense? So if I ask you to compare basics of human cognition versus AI, someone give me a dimension to compare them against. Okay, let's do something simpler. Unless you want to explain that.
Sensory inputs, the input feature inputs.
Okay, so the dimension will be inputs. Explain that.
Humans learn with like lines and colors and stuff, and AI learns from other things like
Numbers, just say abstract numbers, tokenization, whatever. That's one way to look at it. Another one to say is structure. And we might say that AI is built with mechanical metals, silicon, whatever, and humans are built with, well, we still got like 2 minutes, people. It's a biological system. So we could say like the systems are different. We say the inputs are different, whatever. Does that make sense? We really want you to focus on identifying, comparing them, but then also identifying what it is. So if you see a compare and contrast problem, it will not say, it might actually. If you see a compare and contrast problem, give me, I'm going to look at what you say for each one plus the dimension. There are 3 parts. So if it says compare and contrast IMKB in 2 ways, you need to give me 6 things. 1 dimension, 1 explanation for each, 1 dimension, 1 explanation for each in the comparison. Does that make sense? So apparently I have 3 minutes left. I think this was good. What we will do for the, because we are running out of time here. I want to find the lockdown browser. Okay. So this is what I will tell everybody to do. If this is a 50-minute exam, and we have an hour and 15 minutes. So this class used to be 50-minute, 50-minute, 50-minute. I have not expanded it because I don't think there's no real reason to. Trying to be nice too. But I will post an announcement with this PDF. It is very clear as to what to do. I say that as somebody who also does work with computers and as somebody who is a scientist who uses computers and not a computer scientist. Downloading things can be very difficult. So let's just walk through it. You will click this. You might have to control, then click. You will click download. If this gives you any other location, remove your VPN or whatever you're using and just download here. I'm going to download this on this computer because I have, just to show you. I don't know if it'll actually work. Okay, so I can't do that here because I have to be an admin, but you will just install it on your computer. You will open it up, and that's it. And I will go around to everybody, making sure that you have it installed. If you do not have it installed, and you have not talked to me about it, you cannot take the test. I will also be here 20 minutes early if you have any issues, but you will see an announcement. Download the lockdown browser. It should be fairly straightforward. Are there any questions? We have a minute left. Gonna milk it.
Do you have an extra monitor?
Extra monitor?
Yeah.
We can make that happen.
Okay.
Yeah, we can make that happen. Yes?
For the learning portfolio that's due tonight, is it
Oh, yes.
1 connection or 2 connections? Is it for the...
Yes. Okay, for those of us that were not here last class or there's confusion, I took out the SMART goals, which was like the 4th thing. So now you have 3 things. But to substitute that in the knowledge map, instead of 1 description of the connectors, I want 2 description of the connectors. I will make an announcement reiterating that, and I will update the assignment. Is that clear? Yes. 2 connectors. Okay. You're free to go. It's 3:15. I can't hold you here. I appreciate it all. Thank you.